So you've created your basic game world, made or imported some assets, and built both a character controller and can fire projectiles. But as we can see, there's no code yet for projectile interactions. This seems like a simple task in Godot 4, but it can be surprisingly difficult to do in a clean and reusable way. First, though, let me introduce myself. I'm David. I've been programming professionally for over a decade in business and web systems, but I've also kept a love for hobbyist game development close to my heart since I was a child. I'm hoping that I can bring my knowledge and experience of software development to the public for game development. So hello and welcome to my first video on this channel. I hope you find my channel useful and educational. But with the formalities out of the way, let's get back to our problem. How can we get our projectiles to interact with the asteroids? And how can we future-proof our projectiles so they can collide with a variety of other objects as we introduce them into our game? We have a few options. Those options are signals, method calls, and we've got a few other options down the line as well. And one of those will be what we will be introducing to solve this particular problem. And we'll get to that later. For now, though, let's have a look at signals. Now, signals are useful. They're intrinsic, but require communicating objects to be known ahead of time. For instance, buttons on our user interface communicate to other UI elements, but also elements are known at compile time and are easy to connect. Since our bullets are created on the fly, we don't have that luxury. A bus could work, but is inefficient in this case, as any collision occurs, all subscribers will be notified. There's something called method inference. It's a common solution, but it's a bit invasive and subject to typos since raw strings are often used for the method lookups. We also have object detection. It's effective, but quickly becomes unmanageable when new collisions are introduced, as new types must be added to the whitelist. So, what other options are there? Relays. This is the solution we'll be using. Relays are incredibly useful in a variety of applications and work perfectly for executing collision code and area triggering, but they are also abstract enough to be used in a large number of situations. They can often be used in place of or in conjunction with signals. Unfortunately, Godot does not have a native relay system, so we'll need to build it. Fortunately, Godot does have some useful devices which allow us to easily build a message relay system. We'll be using object metadata to store receiver information. We'll also be using a strange quirk of Godot that allows us to safely pass messages to objects, script names. You can use script names as a message to force the compiler to check for typing errors instead of using raw strings. In this case, Godot will actually pass a script to the function, which can be used to distinguish which message is being sent. It may sound complicated, but it's really not. Let's have a look at how relays work. And basically, this is going to be the entire code of relays. Essentially, it's just a class. We're just going to extend object. You don't really ever want to create an instance of relay. The functions we will be using will be statically typed so that you can access them directly from the class name without an instance. If you're concerned your users might accidentally instantiate a relay and create a memory leak, you can extend refcounted, and that should take care of that particular problem. As I said, we'll be reaching into object metadata. Because of that, we're going to need a place to store our meta key. And so we're just going to create a constant with the string messaging where we'll be storing all of our receiver information for the relays. Here's where the magic starts to begin with our first static function, receive. Receive happens whenever an object receives a message, as the name implies. It's a pretty simple concept. It takes a source, which will be receiving a message, the message itself, which note is of type script, and it takes a callback, which is a callable, or in other programming languages, this would be a function name or function pointer, a delegate even. The first few lines here are simply just checking to make sure that the information that we are passed is valid. We are required to have a source. So we're checking for that. We're also required to have a message. Now, the final thing here to check on, we should probably also be checking to see if the callable is valid. But the more important thing to check on here is that our message actually inherits from CR message. That'll be the class that we end up creating in just a little bit. That will be our message token, if you will. It's basically just going to be a base type. And anytime you want to create a message, you'll simply extend the CR message, and that will make that type a message. Now, what is a CR message? Well, it's just that. It's just the message itself. The class, as you're about to see, is pretty much empty. There's not a whole lot to it. There's not a lot of data that's there. It's really just a token that helps us distinguish one message from another. All right. So now what we want to do is check to see if the source object has our meta key in its metadata. If it does, we retrieve it. And if it doesn't, then we're going to create it. And then we're going to go inside and see if the message that was passed is inside that set of meta keys. If it is, then we basically set the callback. Or actually, in this particular case, I'm sorry, I have the logic flipped here. If we don't have that particular message in our dictionary, then we create it and we pass our callback inside of an array. That's why we got to make sure you got those brackets here around callback, because otherwise it's going to just give you the callback itself, or it's going to assign it just the callback. And we do want to keep the possibility that you may want to have multiple callbacks for a particular message. That could come in handy in the future. In my experience, it's not a feature I use very often, but still, it's nice to have it. So we'll go ahead and introduce that. If we already have the dictionary, though, we'll just go ahead and push the callback onto the pre-existing array, and we're essentially done. We're going to go ahead and set the metadata back to the source. If the metadata already existed, I think this line of code ends up optional. However, in the case that the relay does not already exist, then we do need to set the metadata for this. So in all cases, I just erred on the side of safety and just always reset the data back. We also have an ignore function. I'm not going to go too far into this, but effectively an ignore undoes what a receive does. In signal terms, when you connect a signal, ignore is the same as disconnecting that signal. So where our receive is receiving signals, ignore is going to then ignore those signals. You'll most often see this in an enter tree, exit tree context, where the enter tree will call the receive and the exit tree will call the ignore. They'll have the exact same parameters passed. You're just going to be calling one in place of the other, essentially. Okay, and that's it for receiving. So it's pretty straightforward so far. It's not that complicated, I don't think. The sending is really not too bad either. Here we have our static function for send. We're using send underscore v as the naming convention. The reason for that is because in Godot, if you pass a function call and you want to provide the parameters at the end of that function call, you could do that with just a send call, ... and then you would just pass all of your parameters at the end of that function call. The problem is when you're writing your own functions, Godot 4 does not yet allow us the ability to pass a variable number of arguments at the end of a function call. But in place of that, they will allow you to pass an array with all of your function data. And whenever we do that in Godot, they almost always suffix it with underscore v. And so that's an indicator that the values that you're going to be passing to the function will actually be passed inside of an array, and then those will be forwarded as the parameters inside the call and the future call. So I hope that makes sense. If it doesn't, don't worry too much. It's just good sense to call it send underscore v in this particular context, in case this gets updated with the new features that will allow us to pass parameters directly. And don't worry, I will show you how to call this function safely and properly. It's really not that difficult. Just make sure it works the way as seen here. All right, once again, we're doing our assertions. These are our preconditions to make sure everything is as it's supposed to be. Then, once again, we're going to get our relays, and within the destination object, and we're going to search for the relay of the particular message. So the receiver, I should say, for that particular message. And again, that message is a script. So you will be passing the name of the script. And then we just simply go through the array on the other end of that, and we call every single receiver that is in there, passing our arguments to it. And that's it. At this point, you now have a fully functional relay system. That is what all of this code does. It just gives you that relay functionality. So it's not too bad for, almost half 100 lines of code. We're a little over, but not too bad. Pretty impressive, I would say. All right, so now what does the message look like? And like I said, it's really simple. This is it. It is, at the heart of it, an empty class. It just has a class name of CR message, and it extends, in this case, ref counted. For some reason, in this particular case, I decided to guard for if people actually create instances of this. So if you accidentally create an instance of a CR message, it should garbage collect, but you really should never have to create these. You could arguably pass these to the argument list if you want to structure the arguments that are passed, but I traditionally don't. I usually just pass the arguments in the order that I need them, and that's pretty much it. So whatever convention you end up deciding to use your relays for, whether you want to expand out each and every message or just do it the quote-unquote easy way, I'll leave that for you to decide. But for now, yeah, essentially that is the entirety of the relay system. So let's go ahead and see how they work. All right, here is our projectile class, as you can see. In our example, I'm going to be extending area 3D. That doesn't matter. You can extend anything you want. Since we're working within the realm of physics, you probably want it to be some sort of physics body. That could be an area 3D. It could be a rigid body. It could be a character body. There's a variety of different things. I'm also working within the realm of 3 dimensions, but there's nothing that says that you have to. You can work in 2 dimensions. You can even work in 1 dimensions if you know how to get that to work. So do as you will with this. Effectively, what I'm getting at is the relay system is incredibly flexible and does not really care about the types that it's interfacing with. You can do it with anything you want, and that's pretty cool. So, but again, for this, projectiles, deciding to use area 3Ds because I'm not planning on implementing ricochet effects or anything crazy like that. So, all right. Well, here's where things get interesting. Now on line 4, we have our projectile collision message. This is a class definition that extends CR message, and you'll notice all it does is pass. That means this is an empty class. And as we saw previously, there's nothing in a CR message. It's just an empty class. So we're also here in emptiness, basically. There's just no implementation to these. They're very simple, very straightforward. They're simply marker classes that allow us to distinguish one message from another. Now on line 6, I've got an ownership check. This is something that gets set in my code in other places that makes sure that we don't accidentally collide with the shooter. And you'll see that in use later on. But effectively, this is less important, so don't get too hung up on the owner thing. All right, we're going to go into enter tree. Now, here on line 9, we have body entered.connect. Actually, I should back up a little bit. Func enter. If you're not familiar with enter tree, this is called whenever a node comes into the scene view, essentially. And likewise, we have exit tree. This happens anytime it gets ripped out of the scene tree. Typically, that happens when the node is destroyed, although it can be removed manually without destroying the node if you desire to. In this particular case, we're using this as a cleanup, like setup and cleanup code, where once our projectile enters into the scene, we then connect to body entered. We connect the body entered signal to our body entered function. And then that's really all we care about is if something has come into contact with our projectile. When we go into our exit tree, though, we are simply cleaning that code up and we're saying, hey, we're no longer going to detect body entered collisions, so we're just going to disconnect the body entered from the body entered signal. That's it. And again, this is basically straightforward, nothing out of the ordinary right now. Very common Godot 4 code. So you've probably run into this in the wild in previous tutorials or what have you. Where the fun starts is here in the body entered function. So once a collision occurs, Godot passes us the body that collided with our projectile in this case. Now, like I said, the first thing we're going to do is make sure that if the body is the owner, essentially the person firing the projectile, we want to exit early because we don't want to accidentally kill ourselves. That would be very embarrassing. So we just ditch out early in case the body equals the owner. We return, and that's that. Then we hit our CR relay, and this is where the magic happens. CR relay then calls a send V. It says, I'm sending the projectile collision message to body. Body is the collider on the other end. It's very important to realize all we know about the body at this point is that it's a node 3D. Beyond that, I don't have a clue. It could be an asteroid. It could be a spaceship. It could be a planet. It could be anything. I really don't know. But all we're going to do is we're going to tell the body, hey, we're going to relay the message, hey, you just got collided with a projectile. And then you'll notice on the third parameter on line 17, we're sending self. Self means I'm the projectile you collided with. But the most important thing to notice here is that self is wrapped in brackets. Those square brackets are important because, like I said, that send V from earlier, it expects your parameters to be passed in as an array. So you can have multiple parameters passed in here. You could have self, comma, 0, comma, hello world. It doesn't really matter. You can send as many parameters as you want. Be aware, though, whatever your receivers are should be expecting the same number of parameters. So if my send V sends 3 parameters, my receivers should also receive 3 parameters. Otherwise, they will not work. Sadly, far as I can tell, if you mess this up, it fails silently. It's a little hard to detect that. So that is the one gotcha of this system. But just make sure that you're sending the right number of parameters and things will go pretty well. Then we have our destroy, which basically just destroys the projectile. I leave this for the user to fill out or the viewer to fill out. You basically just want to create your fancy particle effects and then eventually call Q free on your projectile because we obviously want to destroy the projectile when it collides with something. In this case, we're colliding again with a probably an asteroid, although this will work with any collider regardless. And I want to go back up real quick to line 17. I wasn't quite finished with that. If it collides with an asteroid, we're going to write code for the asteroid that will handle a collision message. But what happens if the receiver doesn't have a collision message? Well, it basically just fails silently, and that's what we want. Because there can be a variety of different objects within the world that something can potentially collide with, specifically projectiles. Not all of those will react to a projectile. Some of it might be static geometry that all we need to do is destroy the projectiles. So we'll send the message, but if something on the other hand isn't receiving a projectile collision message, then that's fine. That's normal processing, and we just silently ignore it and move on. You don't want that throwing an error if there's no receiver on the other end. Just let it go, basically. All right. So effectively, that's it. That is all we need for our projectiles to handle collisions. Now, obviously, the movement of the projectiles, the lifetime of projectiles, all that kind of stuff I've omitted for brevity. That would be stuff you'd want to probably put in here or potentially in another class. That's for a future video, where you could basically have the normal day-to-day projectile motion. Okay, so now we want the asteroid to explode. What's that going to look like? Well, we're going to call receive on the asteroid. So here's our asteroid class. Now, this is obviously going to be a rigid body because it is a thing spinning in space. We want colliders to be there. You probably saw earlier my ship actually collided with the asteroid and it bounced. That's why we want that. So we're just going to leave a simple rigid body, but real quickly, this could technically be anything you want. Doesn't matter. We're dealing with projectiles, so a rigid body makes sense. Once we get to the ready, now I told you could do the receive and ignore through the enter tree, exit tree. For this particular example, I thought I'd just keep it simple. So instead, we're going to use ready. And ready happens after the object has been added to the scene tree and everything else has been added. And basically, we're ready to go. Then after everything's been kind of set up within the tree, the ready call gets called. And this is not exactly your constructor, but it's like right after your constructor gets called. In Unity, I think it's called start is what this one would be called. So if you come from Unity, that should probably make sense to you. Okay, so inside of here, we're going to do our receiver, our initialization for receiving. And to do that, we just call CR relay, and then we call dot receive, and then we pass who is receiving the message. That's us, the asteroid in this case. So we're going to pass self, and then we're going to say, hey, I collide with projectiles. So if we go back again real quick, we have our projectile collision message right here on line 4. That is also used down here on line 17. We just call projectile collision message because we are currently inside of the projectile. But since we're now inside of the asteroid, we need to say, oh, by the way, this message is found in projectile. So we do projectile dot and then projectile collision message. So that hooks up to the exact same message. Okay, and then finally in that third parameter, we're basically just specifying a function, and that function is what should happen anytime we collide with an a projectile. And in this particular case, our function is called damage from projectile. You'll notice that we do not have an open and close parenthesis at the end of damage projectile. We're not calling it, we are referencing it. So you want the name of the function, not calling the function. And then the function is defined right under here on line 7, where we receive the projectile as an argument. In our case, we're just going to print asteroid hit by projectile, and then we're going to destroy it. And just like the projectile, I leave this for you to fill out. This is a simple stub. In my particular example, we are going to be having some nice little special effects and things like that. So basically, that's it. We now have our relay constructed. We now have our projectile sending messages to other objects, and it doesn't have to know what those objects are. It just simply sends them when it collides with them. And then for our asteroid, we have our receiver, which will receive messages from projectiles that are colliding with it. And as you can kind of see here, this is very extensible, because what happens, for instance, if I have a starship and the starship should be hit by projectiles? Well, I don't have to go into the projectile anymore. All I have to do is when I'm writing my starship code, I just simply add a receiver that says it collides with projectiles and then provide a corresponding callable or callback that handles that particular interaction. So as my list of things that can be hit by projectiles grows, I never have to reach into the projectile code and modify it ever. I can do all of that inside of the thing that is reacting to that particular communication. And that helps keep things more extensible. And it's a fantastic way of working. It works very similarly, I would say, to the method inference. So effectively, you get the benefits of method inference, but unlike method inference, it's a little less invasive. And you also don't deal with the typo issue, because projectile collision message, if I mistype that, guess what? The compiler will notice and it will give me an error. So I don't have to worry about typos in that particular line. So it's a pretty fantastic way of working, but let's see how it goes. So let's go back to our space game here. And right now, again, just to illustrate, if I fire at a rock, nothing happens. But once we install our code, now collisions occur perfectly through the relay system. And now I can go around blowing up as many rocks as I can. And as I stated earlier, if you don't mind me doing a little bit of flying around for just a second, we can extend this to other objects. In fact, outside of the code I showed you, I went ahead and for spaceships, I also added receivers for spaceships and projectile collisions. So here we are. This is another one of the ships just like ours. And if I shoot it, there it goes. It blows up. So there we go. 2 interactions. And we never had to modify the projectile code once to add that second interaction. We just simply added it to the ship itself, and it told it how to interact with projectiles. And that basically is that. So, all right, I guess that's pretty much it. So thank you guys for watching. The relay code you've written for this case can be put in a folder and dropped into any Godot 4 project. They're easy to use and have wide application. I hope you found this tutorial useful. I have ideas for more videos, including more coding tutorials as well as art tutorials, specifically using Blender. There's a wide variety of topics I want to cover on this channel. If you're interested in more, consider liking this video and subscribing. so you'll get notified the next time I drop a tutorial. Thanks again, guys. Hope you guys really enjoyed this video. Enjoy relays, and I hope to see you in the next one. God bless.